Hello folks, today our task is to determine the density of some solids and liquids. More specifically, we're going to determine the density of an unknown solid and also determine the density of an unknown liquid. We're going to determine the density of the unknown solid by a method called water displacement. That is where we take the quantity of solid and place it in a volume of water, and we're going to measure how much the volume of the water and solid together increase. So let's go ahead and follow our procedure. Finding the density of metals, we're going to go ahead and measure the mass of each metal. I've been given two metals. One of them is copper. It is labeled copper. The other one is labeled metal A. So let's go ahead and measure the mass of both of those. I have a balance in front of me. Balance is on. I'm going to place an empty cup on the balance and I'm going to zero it. So I'm going to tare it. That literally subtracts out the mass of that cup, and then I can go ahead and add the copper to the cup and then measure it. And that number that I read on the balance is exactly what this copper weighs. So 50.63 grams. 50.63 grams is the mass of the copper. All right, let's go ahead and do the same thing with metal A. Again, I place my empty cup. I ensure that it is still reading 0. And I'm going to put metal A in the cup. And it weighs 24.85 grams. And I'm going to make sure to circle letter A in my data chart. All right, my next task is to go ahead and fill a graduated cylinder halfway with water from the sink. I already have an Erlenmeyer flask here with water from the sink, and I'm going to fill it up about halfway. Doesn't matter how much it is exactly, but I will need to record exactly what it is. So I'm going to go ahead and read the bottom of the meniscus, and that means I'm going to have to get it eye level, and it looks like it's reading about 62.0 milliliters. So 62.0 milliliters is the initial volume of the water. Then I'm going to go ahead and add the copper, and I'm going to do this so that I don't splash. So I'm going to hold my graduated cylinder at an angle and let the metals slide in. Now I'm going to read the meniscus again. So let's check. And now it is looking like it is 68.2. 68.2 milliliters is the final volume. All right. Now I'm going to do that again with the next metal. So again, I have my graduated cylinder. I'm going to fill it halfway with water. I'm going to go ahead and record the volume. And it looks like it is reading 64.9 milliliters. Then I'm going to go ahead and add my metal A into the cup, into the graduated cylinder, gently again so that I don't splash. Then I will read the volume again. Putting a piece of white paper behind it often helps to bring the meniscus, let it stand out. So let me go ahead and read this. This is now reading at about 74.5. Again, this is milliliters. All right, so I've just done the first part. The next part is to determine the density of my liquid. Now, obviously, I cannot determine the density of a liquid using the same method as the solid, because obviously we're dealing with a liquid. So I need a container. So I'm going to choose an empty container, and that's going to be a graduated cylinder. So I'm going to use a small graduated cylinder, and I'm going to determine the mass of the empty graduated cylinder, and it is reading 25.79 grams. 25.79 grams. Now, I'm going to add a little bit of the liquid to it. It does not matter how much I add, but it is recommending that I add approximately 5 to 7 milliliters. But again, it does not really matter. So now I've added approximately 5 milliliters or so, and I'm ready to determine the mass of the graduated cylinder plus the liquid. And it is reading about 4.80. 4.80. Oh, sorry, that's the volume. Sorry, I apologize. 4.80 milliliters is the volume, and the new mass is 29.66 grams. And now we've collected all our data, and we're ready to go ahead and do the rest of the experiment.